Alright guys, today we're going to go over the study guide. We're going to do part of this today. As you can see, there is quite a bit, about 3 pages. So we'll do some today and we'll do some tomorrow to finish this out. Alright, so we're looking at problem 1. If line segment PT is tangent to circle 0 at point P, how many degrees is OPT? So what they're asking us is how many degrees is this angle right here. Okay, we should know that anything that's tangent to a circle, a line that's tangent, means it's going to be exactly 90 degrees in this middle spot right here. So that means angle OPT is equal to 90 degrees. Okay, remember tangent circle, if it comes off the end, coming from the middle, that's always going to be 90 degrees right here. Always. Okay. We go to number 2. In circle D, the measurement of angle C, so right here, is 40 degrees. What is the angle measurement of B, and what is the angle measurement of A? Okay, so number 1, we have to find out B. So we know that in a triangle, it has to be, 3 angles have to equal up to 180. So we take 180 minus 40. It's going to give us 140 left. If we really look at that triangle though, how it's set up, that means angle B is going to be a 90 degree angle because it's a right angle right there. Okay, if it was set up a little smaller or whatnot, it'd still be the same. So we know angle B, is equal to 90 degrees because this, you can tell, is a right triangle. And angle A, so we know that if we take 90 away from 140, ends up leaving us with angle A is equal to, like I said, we take 90 away, that's going to leave us with 50 degrees for angle A. And let's just double check these, add them up. 50 plus 40 gives you 90. 90 plus 90 gives you 180. It works out. Given circle 0 below, find the exact values of the following. Leave pi in your answer. So that means we are not using pi to fully answer. We're leaving it as a number pi. Okay? So I'm going to get to the point on our stuff here. So, excuse me. This is a couple assignments ago, so I'm going to go try and find it. Give me a second, guys. Sorry, I'm trying to pull up my notes to help you since we're doing it this way. I think this was under lesson 2. Let me just pull up and double check. If not, I'll pull up number 1. So we're trying to find the length of A, or arc AB. Okay, so I'm just trying to find my arc notes. That's an area segment. Nope, I don't want that. Sorry guys, give me 1 second. I'm just scrolling through the notes. That was not there. Alright, give me a second to pull up lesson 1 that we did in class. There it is. Let's find the arc. Okay, there it is. So, when we are trying to find an arc measurement, let's see. I'm just checking to see, make sure I give you guys the right thing. So what they end up doing, sorry guys, what they're giving me on this notes is, I'm just trying to refresh my brain so I can give you the right answer. All right, here. How do we get that? Okay, I'm going to take a look on the notes here real quick, guys. So what we did here will help us tell. There you go. So we're using this formula. It's in the work example. I'm pulling up on my other notes, so I have it. There we go. All right, so we go back. We're going to be using, to find the arc length, m over 360 times 2 pi r. Okay, so now the m is the measure, so that's 60 degrees over 360. We're going to do 2 pi, and our r is going to be 12 because this is our radius right there. So we can figure this out because we're leaving pi in. So 2 times 12 is going to give us 24 pi. And then if we take 60 over 360 in our calculator, so you have to use the alpha y equals 60 over 360 is going to give us 1/6 times 24 pi. So take 1/6 times 24, leaves you with the answer of 4. And because they told us to leave pi in the problem, it's just going to be 4 pi as our answer. Okay, so when it says leave pi in your answer, you do not multiply it by pi, you just leave it as pi. So as a reminder, I'm going to write the formula here, and I would advise you guys doing the same because you can use this study guide to assist you. So I'm going to say right here, arc equals m over 360 parentheses 2 pi r. So I'd leave that right there so you can see this. I would put a box around it, something that draws your attention, because if you pull your study guide up on a computer in Canvas, or if you print this, which if you have a wireless printer at home, you should be able to hook it up to that and print. If not, let me know. You can send it to me and I can send it back to you in an email, and you can pull it up on a different computer or iPad or phone and use it to help you. So just let me know. I'm here to help you guys as much as I can. Now they're telling us to find the area sector of AOB. So let me just look and remember how we found our area sector. So we want to find out how much in that area that is. Okay. So checking back in our notes to check and see. We got arc length there. Find the area of sector AOB. Let me see if our other notes have it. Sorry, guys. I'm checking worksheet number 2 to see if it's in there. There we go. So, area of a sector is, so I'm going to write here, area of sector is m over 360 times pi r squared. Okay, so now we know our numbers again. So we know 60 over 360 and pi 12 squared. We know 60 over 360 leaves us with 1/6. And then we're going to times 12 by 12 or 12 squared, which comes out to be 144 pi. Now, we are not done yet. We have to still simplify this. We have to times 144 by 1/6. So if we do alpha y equals 1 divided by 6 times 144, we are left with 24 pi as our answer. So again, here is the formula. I'd box it or something in the highlighter so you see which ones are the formulas and which ones are answers, so it can help you find that later. Okay, I want to make sure you guys pull these formulas out because I'm writing them here that you can use these. The study guide can be used on your test. Okay, so in circle A below, the length of the diameter is 10 centimeters. And measurement of BAC is 110 degrees. So right now, this is going to be talking on standard 1.1 is just being able to annotate it, write down what you need to write. So they're saying that the diameter is 10 centimeters. Diameter, not the radius. Diameter would be this long here as 10. So if we're talking about half of that would be 5. So if you can write 5 cm like this there, and then BAC, so the angle here in shaded is 110, they say. Being able to do that right there helps me be able to show that you can do standard 1.1. That's annotating. So right now we just annotated writing down what the problem says. It says find the approximate values of the following, round 2 decimal places. So what that means is now we are going to be using pi. Okay, so we're going to multiply pi into there. Now, it says find the length of arc BC. So we have our measurement, our formula over here. So we know it's going to be 110 over 360 times 2 pi, and we said our radius is 5. Okay, so 2 times 5 is 10 pi. And then doing our alpha y equals, type in the 110 over 360. Will leave us with 1136 times 10 pi. So now we just take 1136 times 10 second and the caret key, which gives you a pi symbol. And it leaves us with the answer of, I'm going to write right over here on top, 9.599. So they said round to 2 decimal places. So we have to round that third number. So it's going to be 9.60 centimeters. Because that's what we're talking about is centimeters. Okay? That is your answer. Find the area sector of BAC. Okay, so area of this one. Once again, we see the formula over there on the side. So it's going to be just plugging the numbers in again. 110 over 360 times pi 5 squared. Now, 5 squared is just 25 because it's 5 times 5. 110 over 360 we said was 1136 times 1136. So type it back in, 1136 times 25 pi. Leaves us with 23.998. So now this is where we're going to round up. It's just going to be 24 centimeters because we round the 8 up on the 9. Makes that a 0, rounds as 9 on the other one, leaves us at 24 centimeters. Or, I'm sorry, 24 centimeters squared. So you can just put a little 2 up there for squared because its area is always going to be squared. If you have any questions on this part here, please reach out to me so I can assist you. we're going to do these last two today, and then we'll do these other ones tomorrow, and I may finish this up on Monday, and then we'll do our test on Tuesday next week, possibly. All right, now we're looking at this next section where it's talking about find the exact value of shaded regimen in GB, or if GB equals 8, write your answer in terms of pi. So that means we're leaving pi in the problem. Okay, we're not taking pi out. Excuse me. So GB, our radius is 8. Okay. So in order to do this, let's just double check in our notes. So we got to find out our area of the circle. So area of circle is equal to pi radius squared. Okay, so that gives us at least finding our area. So that means our area is 64 pi. And that's because 8 squared, 8 times 8 gives us 64. Okay, so we know that's the area of the entire circle. Now we have to find out the area of let's see. I'm looking at one of the problems that we did in the past and just seeing how they got to this. Actually, we got that. We're going to find out an area of a sector, okay? So we're going to use our formula up here and find out. So the way we're going to do this is that we know that the area of this is 64. So actually, let's just erase what we wrote here, okay? I'm sorry I made you guys write that, but I'm going to show you a little easier way of this, especially since this is a right triangle. So we're finding the area of this sector. So we know that this measure essentially is going to be 90 over 360. Because we have that angle measure right there telling us that, which turns into being 1/4. Make it simple right there. We know by looking at this formula it's going to be pi, and it's going to be radius squared, which is going to be 64. Okay? So I'm going to write 64 pi. When we times all this down, it's going to end up being 16 pi. Okay? We know, or hopefully know, so we're going to leave that like that there. That's not the final answer. I won't box it. I'm just going to put there. We have to find the area of a triangle now because we've already found essentially what an area of sector is. So now we got to find an area of triangle and then subtract. So, area of a triangle is equal to 1/2 pi times 8 squared. Okay. So, doing half triangle pi 8 squared ends up coming out to being, and we're going to use pi in this one, comes out to being 32. Okay. So essentially, all our area of this segment is 16 pi minus 32. So we're trying to find out what the shaded is. We take the sector, what is this part here, subtract it from 32, which is a whole triangle, is what it's going to give us our answer. We obviously can't make it any smaller than that, so that answer works. Okay? Because it's essentially 1/2 base times height. We have it right there, or I'm sorry, area of a segment. I'm going to give you the formula right here. Area segment is m over 360 parentheses pi r squared minus 1/2 base times height. So essentially the 8 times 8, 8 squared is where the base times height, because the base of the triangle is the same. That's where I got the 1/2 pi. And there's your answer. Okay, actually I should delete the pi because the pi makes no sense there. I'm sorry, guys. There's your answer. Actually, I'm going to do this. I'm erasing just the box because I want to put a bright pink box around it so you see that this is a definition and formula you can use. So if you guys want to write these 3 that I've written so far on a separate sheet of paper, that is fine by me. You can use that on your test. Last one, and then we are going to be done for today. So Tyler's packing his lunch for tomorrow. The Tupperware he has is able to fit 120 square inches of pizza. If the radius of the pizza is 9 inches, so you can draw this here, it will help you see this. I'm just shading my line. Draw 9, and then you can 9IN, and the pizza is cut into 6 congruent slices. How many slices will fit in his Tupperware? Sorry. So we're trying to figure out, let me see if we have a note on this. I don't think we do. So we can figure this out, that each slice is 60 degrees in the middle. Okay. So we have to use the, not arc measurement, I'm sorry. We have to find the area of the sectors, okay? Because what we're doing is we're going to find out how many of these that we can fit. So what we're going to have to do is it's going to be 60 over 360, because I'm going to use the area of a sector, times pi r, our radius is 9, squared. Okay. So 60 over 360, again, is just 1/6. 9 squared is 81, because 9 times 9 gives you 81. Pi, if we times all this, 1/6 times 81, and we're going to use the actual pi symbol, comes out to be 42.41. Now, his lunchbox can fit 120 square inches. This is 42 squared inches per slice. So this is a big pizza. Okay. Now, we have to see how many of those we can fit into his lunchbox. If I take that number times by 2, that works. If I take the number times it by 3, it does not work. Comes out to be 127. So really, he can fit 2 slices of pizza in his lunch box. Okay, I hope you guys kind of see where I got that. If not, please let me know, so I can further help you guys figuring that out. I just don't want you guys getting lost and confused on how that's being done. That's all I'm going to do today. Tomorrow we'll pick up and do the next page. And then after that, we'll do the rest of this more than likely Monday, because if you guys do not know, Friday you do not have school. Have a great day, and I'll talk to you guys soon.